Hey guys, I just wanted to give you a quick tip on this question, and this is one of the questions I took from a previous paper, and it is actually good for you guys who are doing your N3, even N4, or actually if you are just want to ensure that your basic algebra is in check. So I just want to take a look at this question and how I approached it. So it's two questions. The first one I'm going to simplify. So I've got this question, it was out of 5 marks. And the second question, it says solve for x, and it involves logs. And I was actually intrigued by the 8 marks to say what kind of a question can be worth 8 marks and what does it involve. So I just want you to stay tuned and just see how I approach these questions. So the first one, as you can see, it's a question that is worth, as I said, it's a question worth 5 marks. So how do you approach it? If I can just copy it down here again, it says here, if I'm given, in this case it's in brackets, x minus 2 plus x to the power negative 1 all raised to the power half times, in brackets, x minus 1 over, this is x to the power half. I'm just trying to write it down so that I can make it. And then this is raised to the power negative 1. Just to check it again. Alright, so this is 5 marks. So how do I approach this question in a way? Let's just hide that. I've got this question, and the first thing you need to do here is to just look at that power negative half. That is x to the power negative half. Remember, x to the power negative half is same as saying 1 over x. So that is the first part there. So I'm going to express that now as bracket x minus 2. Now it's plus 1 over x. You see that? But this is still raised to the power half. And then it's times. Now, I just want to show you again how you can simplify. If I'm given, for example, a to the power negative 1 is equal to 1 over a. Just it's the same thing as the top. But now if I'm given, in this case, a fraction that is a over b to the power negative 1, this is same as 1 over a over b, which is equal to, if you continue, this is 1 divided by a over b. I'm taking this as the division sign. Now you have to convert now to a multiplication, and then you invert. This goes up, this goes down, which is now b over a. So in actual fact, you can see that a over b to the power negative 1 is the same as b over a. I think you can see that. Now, if I can use that concept here, I'm given, in this case, x minus 1 over x to the power half to the power negative 1. So I can actually conclude and say this is same as x to the power 1 over 2 over x minus 1. It is now to the power 1, but you can ignore that power 1. I'm using this concept here to say a over b to the power negative 1 is b over a in that case. So now these are the things that you need to always bear in mind whenever you're working with such. So the next thing is to solve this bracket. I need to get rid of that fraction there. It's 1 over x. So the common denominator there is x. So I'm saying x, this is over 1, this is over 1. So 1 into x is x, x times x, which is x squared. Another one, 1 into x, it's x times minus 2, which is negative 2x, plus x into x is 1, 1 times 1 is 1. Remember, this is to the power half times x to the power half over x minus 1. Remember this? And then we continue. Now, if you have to factorize this top part, we need to factorize that. And if you factorize that using the product sum or whatever way, you will see that this is actually equal to x minus 1 squared. So if I say x minus 1, if you multiply this time, this is x squared. This time, this is x minus 1, which is minus x, which is minus 2x, and then minus x times 1, which is plus 1. As you can see, that is that. But you need to be able, you definitely need to know how to factorize that. I won't dwell on that. Over x, And then remember, we still have our power 1 over 2. This is multiplied by x to the power 1 over 2 over x minus 1. I saying that, then this continues to say you need now to write this x minus 1. Remember, this is a square over x, but everything is still under power half times x to the power half over x minus 1. I saying that, and then you can now distribute this power half. What it does is the power half will multiply that as a power, and the power half will multiply the x to the power 1. So what you have is we have got x minus 1 squared. So you see how you distribute it. You say times power half, and then you have got over x to the power 1, and this again is times power half. So that's how you distribute that power. And then it's times x to the power 1 over 2 over x minus 1. And then this continues. You can see now that you can cancel that, so that you can get x minus 1 over, now at the bottom you have got x to the power 1 over 2, saying that times x to the power 1 over 2 over x minus 1. This is perfect because when you're cancelling out, this cancels, this cancels, this cancels, this cancels. Actually, can you believe that this thing was just equal to 1? You know, when you start the question, you can say that it is equal to 1. But what I usually advise students is when they're given questions like that, just choose any value of x. For example, say let x be equal to 4. You take a calculator, and when you take a calculator, what you're doing is you want to see how far can this thing go. So you use the calculator to say 4 minus 2, just any number, plus 4 to the power negative 1, remember it's x, just to see, because already the examiner is giving you something that has a simplified way. You see that? So where there is x, I'm substituting that value over fraction x minus 1, which is 4 minus 1. I think that over 4 to the power 1 over 2, and then everything is to the power negative 1. You need to just to be careful to do that. Equal to, think of it, this thing goes to 1. So you could have started by substituting, then you know that it simplifies to 1, then work towards that answer. So that was the first part. Second part, as I said, guys, it's just a quick one. I'm not dwelling much on the theorems and stuff, but I'm just showing you how these things can be. Now, this is the granddaddy of it. It's 8 marks. Look at this one. It says we need to solve for x. But whenever we're solving for x, you need to deal with that that part first. How do we do that? So this one, remember, this is same as square root is same as log base 3 x to the power 1 over 2. That's what a square root means. It's to the power half, because there is a hidden 2 there and there is a 1, so it's 1 over 2. And then plus 1 over 2 is equal to 3 log base x of 3. Now, when you analyze this part, this is the thing that you need to always get note of. Look at the bases. The first one is in base 3, the other one is in base x. So it's up to you which one you want to match. So I want to make everything in base 3. So now, how do you convert? So in this case, how do you convert bases? So what you need to do is you need to know how to convert a base x to a base 3. So there is a formula which says if you're given log base a of b, and I want to convert it, for example, to base, let's say base m. So it will be log base m of b, the b goes on top, over log base m of a, the a goes below. So we're going to do that. We want to convert x to base 3 because we already have base 3 there. So I'll have log base 3 of x to the exponent 1 over 2 is, plus 1 over 2 is equal to 3. Now let's convert that. We said it will be log. Remember, we're converting to base 3. Now the top one there is 3. So it will be log base 3 over log. Again, I'm converting to base 3 and the x goes below. So you see, that is how you convert that. Now a few things again on your logarithms. You know that if you're given log base a of a. If the a and a repeats, that is equal to 1. So you have a 3 and a 3 there. So it's not log 1, it's 1. Sometimes students, they say this simplifies to log 1, then they get it wrong. That is not that. It is equal to 1. Like literally, the whole thing is equal to 1. So what you do here, you continue to say, now another thing, okay, another law, if you are given this part which says log a to the power m is equal to the power, you can drop it down so that is m log a. It can be whatever base, let's say it was base b. So in this case it's base 3, but there is this power that I can drop down there. So it will be 1 over 2 log base 3 of x, you see that, plus 1 over 2 minus 3. Now this part is equal to 1. Remember I said log 3 of 3, which is 3 times 1 over log base 3 of x. Are you seeing that? So that is how this thing first simplifies. If you are able to do that, you have just removed much of the problem in this case, and you are just doing your simple algebra now. First things first, you see there is still a fraction that is a problem, and that fraction is this one, which you need to multiply by it, log base 3 of x, so that you can remove that fraction. But remember, you need to do on each and every one of them. There is an equal sign there. You need to do on each and every one of them wherever there is a plus. So if there is a plus here, as you can see, so in other ways, what it means is I can put a bracket here just to make things easy. Put a bracket and you'll be multiplying everything by log base 3 of x. Remember, what you do on the left, you do on the right. But because of the plus sign here, I'm forced to put a bracket so that I can now multiply that and I can multiply that. So what I'll be having is 1 over 2 log base 3 of x times log base 3 of x, remember, plus 1 over 2 log base 3 of x is equal to 3, because 3 times 1 in this case, because it was 3 and there is this 1 there. Now, that is the part where I usually try to simplify things. In this case, I usually say use the K method now. Now, the K method, what does it say? You let everything be equal to K. So you say let log base 3 of x be equal to K. So whenever you see log base 3 of x here, you put a K. When you see it here, you put a K. Don't forget there is a multiplication sign. When you see it here, you put a K. So let's simplify this. It's 1 over 2 K times K. You see K dot K is K squared plus 1 over 2 K is equal to 3. Again, we are still affected by fractions. Always get rid of fractions. Fractions, they multiply by 2, they multiply by 2, they multiply by 2. So always get rid of fractions so that you've got K squared. In this case, just to simplify it, it will give me here K squared plus, cancel that, you get K. Now this is 3 times 2 here, it will give me 6, but I must take 6 to the other side so that it will be minus 6. This gives me a 0. You see, why am I doing it? Because I need now to factorize. Remember, factorizing, I have to come up with 2 brackets. You can use a quadratic formula, but because of time, I just wanted this to be quick and short. You know, hot and quick, like coffee. You know, it's hot and quick. So let's look at this one. I've got K here. I've got K is the product sum method. So I've got plus 3 minus 2. This is equal to 0. So if I multiply K squared, K minus 2 plus 3 plus K, this is correct. So I've got K plus 3 is equal to 0, or K minus 2 is equal to 0. So here K is equal to, take this to the other side, is negative 3. You see that? Or K is equal to, take this to the other side, is equal to 2. So you've got 2 values of K here. But that is not your answer. That is not your answer. You just said here, let log base 3 of x be equal to K. So now you are saying here, I've got K is equal to negative 3. So you substitute now to say, log base 3 of x is equal to -3. Now, how do you simplify this? It's simpler, guys, but take note. What I do is I write my x to say x is equal to 3, that 3, then this becomes the power, which is -3. So use a calculator. X is equal to, you find what is 3 to the power -3, 3 exponent -3, it will give you 1/27. That is the first one. You do the second one, you say, oh, I've got log base 3 of x is equal to k, but now my k is 2. So remember, in this case, k is equal to 2. So which means similarly, log base 3 of x is equal to 2. Now, how do you simplify this? Again, you do the same thing. Write your x is equal to 3. This becomes the exponent, which is 3 to the power 2. So x is equal to 3 squared is 9. Don't say 6. Some they say 3 times 2 there. Is 3 squared, which is 9. So you've got two answers. X is equal to 1/27 and x is equal to 9. But obviously, you need to test your answers. How do you test? Go to the original. Sometimes you might find that one value is wrong. So let's test it. X is 1/27 or x is equal to 9. So you can test the first one. Remember, when you're testing it, look at the left hand side, look at the right hand side. It must balance. So you've got log base 3 of square root of the first one. We said it was 1/27. Let's see what it gives us there. And then it is plus half. 1/2. This is giving me -1 on the other side. So let me test the other side. So I got -1. So I've got here 3 log base, and then x is 1/27. Remember, I got -1. And then after that, I've got 3. I don't know if I did put a 3 before that. It's 3 log that. And then I get also -1. You see that? It balances. Let's try 9. Let's start with this side already because I've got 9 here that I need to remove. If I delete that, I've got 9. 3 log 9 of 3. I've got 3/2 on my one side. Let's see if it will give me 3/2 on the other side. Log 3 square root of 9 plus half. It must give me 3/2 plus 1/2. It must give me 3/2. It balances. So guys, this is how you solve such questions. As I say, it was a quick one. I just wanted to show you some of this basic algebra that I always want you guys not to mess it up. But if you do much of these, you'll find maths interesting, you'll find your maths more appetizing to do, and once your algebra is in check, most of your maths problems are already half solved. So guys, don't forget to subscribe to our channel, leave the comments wherever you can, give us some other ideas you think you would have solved this, or if you have got questions that you want me to solve, just inbox me on or leave a comment in your YouTube. There is a comment part where you can leave a comment and we can come back to you. We've come to the end of our lesson. Thank you.